What's going on, guys? Welcome back to another video, and today we are using Spelunker.cave, which is the newest Neuroglancer neuron viewing editing web page software thingamajig that we use for proofreading. And there's some new features in this, so I'm going to make a few videos to go over just some tracing techniques, some proofreading techniques, and how to utilize these techniques to become a more efficient and better tracer. So in this video, we're going to be talking about using similar cells to help you focus your attention on the areas that are different. And by doing so, reveal the missing branches in those locations, and then adding those branches to the appropriate cell. And just in general, a guide to help you when you have a tough cell that you cannot find connections to. This is one of the ways that can assist you in finding those tough connections. So let's get into it. I have a couple of annotations here, and we can jump through the annotations using the bracket keys. But without looking at these annotations, I'm just going to turn the crosshair off with the letter A. Without looking at the annotations, when I see this cell, this pair of cells actually, which what your task will be might not involve having two cells up at once, but one way that you can find similar cells is you kind of go along the backbone here and you look for any other cells that, or any other, shapes that are kind of doing the same thing, and you just click on those. And as you can see, we can get a couple other similar looking ones. I don't know if they're exactly the same, but that is how you're gonna sometimes be able to find a similar cell, unless it's a singleton cell and there's only one of those on either side of the brain. But there are other ways to find similar looking cells. That is the typical way. Just kind of click around like this here. You can see the flow is kind of similar. That might give you an idea that, yeah, that looks kind of similar. Who knows? In this example, we have a green cell and a purple cell, and I see the green cell has a branch like this, but the purple cell doesn't. So I'm going to want to look in that location, and it looks like there's a branch up here and a branch down there. This one has this branch, but which one is it missing? It looks like it has the branch down there, so this branch is probably that branch. Let's just see what is over here. And as I zoom in this area, like this little break stands out to me, and this almost pointed shape is what I'm gonna be looking at first. And as you can tell, you can see the annotation point here. I'll zoom in. So right here, you can see if I turn the segmentation off by hitting the number corresponding to the tab. So this is the segmentation tab. If I hit 2 on the keyboard, I can turn that off, and that helps me look at the 2D better. So you can see why this branch is missing. There's an error here in the data. It cuts across the whole thing. That error is much worse, but we are not looking at that at this time. But as you can see, there's this kind of thing here. And, usually something, it looks like it has a backbone. I'm going to click that. And it doesn't look like it goes past that. And in this slide, you could almost see that it is connecting. In this slide, you can almost see the ER is like touching it. And it looks like you can see the ER right here is touching the membrane. And it's like really close, almost exactly touching. And if we scroll into the 3D, you can see that it's making like almost a perfect mirror reflected branch. of the green one this way, the green one that way. They got the purple one this way, and the green one that way. So one thing you want to do to make sure that looks like a missing axonal branch. Obviously, we want to get those. It's just following the ER there. That's probably good enough. One thing you want to do to make sure that this wasn't a fluke and that maybe you missed something, and I don't know, maybe it connects to this one or something. Something you can do to double check yourself is you're going to want to go over to the thickest part of the branch here and check if that continues into another cell. So as we can see, there's a little membrane swirl here. We can trace through that. Do the same thing again. It's like it goes to here. And this is looking much thinner now, so I don't think we're going to get much more from this branch. I would guess this is probably the end, or the enough of a branch that we probably don't need to get any more of it before it's becoming quite small. Looks like we maybe could trace to this yellow one, and then yeah, it's kind of done. So what I was looking for was the missing branch that the green one had, but the purple one didn't. So I checked in the vicinity, which I would say anywhere from like here to here, that branch could be. You know, things that stick out like this. This one's pretty thin. This one kind of looks like, if we checked here, there might be something. As you can see, it's just a little area where it's disappearing. If we get rid of that again, you can see it kind of telegraphs that it's coming to a branch by sort of curving up like this. And on this side, it's, you know, if there were no branch there, it would probably just go like that and kind of connect. So this sort of triangle is indicative of a branching point. And then we followed it to the end to make sure that this end didn't connect to a different cell. Because if it did, we would want to double check our assumption that this connected, but we seem to be correct about this branch. So that's that missing branch. Now we want to find the largest missing branches as fast as possible. So going down over here, it's like I have another annotation point. So in the purple, we have a branch going this way. In green, we have a branch going that way. In purple, we have quite a large branch going this way, but we don't really see a green one over here. So there is a smaller green branch, but as we did with the previous branch we found, we want to go to the tip here and just make sure that it's fully traced. So it looks like there's another membrane swirl that is responsible. As you can see, we could follow the ER in here, and you can see this. There's enough of the cell that you can kind of trace it. It gets a little bulged there, but we traced through, and it's the same size, or I should say the same thickness in branch, so we can be pretty confident that this is connected. But when we scroll out, we see that this branch is part of a different cell. So now we need to determine, is this branch part of our green cell or is it part of the yellow cell? So one thing we're going to do is we're going to just double check our trace again. And it looks like our branch is this part. And if you scroll out into 3D, you can see the direction that the green is going is this way, where the yellow is more going sort of that way. So this could be a branching point for the yellow, but from the looks of it, you can follow the yellow from up here. It looks like it's just passing by, right? And this, you can scroll in a little bit more here. You see the ER. It's kind of pushing up against this membrane. There's no obvious sign, no obvious breakage, or you know, this border is pretty well defined, even though it is messy. And the directionality and the fact that we know that the green is missing a branch makes me think that this yellow branch does belong to the green one. So what we would do is we would split this. You could hit the C key. You could drop a point on here. You're probably going to have to split this from this and this from that. Unlucky or unlikely that you would get it in one split, but 2 splits only takes about 10 seconds. But we're going to save this for trading purposes. So get rid of that. So that's another indication. Okay, well, there's 2 branches on this side and only 1 branch on that side. What's the deal with that? You can scroll down here. This looks pretty good. You could probably grow out this tip and maybe that tip, but we know that we have generally most of the branches down here, and these are quite small. You could probably grow this out a little bit. So if you're feeling like you want to grow out some extra axonal boutons, please do. That's always good. Okay, now we're looking up here. And as you can see, there's a much bigger green arbor, which is interesting. Makes me think that there's some purple missing. There probably is. But let's just take a look up here. We see that there is a dot here. So this branch is thick enough that I would probably investigate it. Where this branch is thinner, but this is also probably going to lead to a bouton. As you can see, it goes through another membrane swirl. We could get that. That's decent. That's pretty good. And let's just take a look at this in depth. I believe there was, yeah, somewhat larger branch, and then I'm going to look back at my notes here. Yeah, I think this was indicative of a branch that you would probably want to get if you could, but as you can see, it's a little bit smaller than those other branches. Now, where the other purple branches are, it's hard to say. I don't think I've traced enough to find that, but this is probably a culprit here. Yeah, it looks like it is pushed to the side here. That's probably going to yield some extra stuff. Kind of small though. I would start by looking along the, this is quite a thick branch. And the green one has 1, 2, 3, 4. Or is this a merger? This is a merger. Yeah. So one thing that is interesting here, I'm just going to put an annotation point here because, hey man, I didn't find those earlier. Oops. So the reason why that didn't drop an annotation is because I'm selecting the segmentation tab and the cut menu is open, so we can clear that. We can hit C to turn that off. We can right click on our annotation tab. We can drop an annotation point down. So if you could conceivably see, use your imagination, if we cut this off, the purple and the green cell would match much more if this large branch was not here. So yeah, I think I remember this now. I was looking at the purple branch. I couldn't find anything. So the order in which you're going to be discovering the merges that you need to make and the cuts you need to make might not always be in the exact same order. This green branch is pretty thick, so probably want to get that. That looks weird. There you go. So there's a little slide jump. You can see this one kind of pops down here. That's a decent sized branch. Always worth getting those types of branches, but in this scenario we have, I would say, 95% of the cell now. If we get rid of that merger, if we add these 2 branches and make sure to split off that part. So that's how you use two similar looking cells to help yourself trace. If you don't have a similar looking cell, some of the things still apply. What you're going to want to do is check the tips of things. So you could, if this cell wasn't here, you could say, well, the cell typically has branches that are about this length. So that's pretty much that length. This is similar length, but like this area, that's not the same length. Up here, you can see this length, that length, similar length, even though it does a curly Q. This one, it'd probably be hard to tell if you only had this as a reference, but it's always good to check these perpendicular connections. Usually it's offset, so it would be connected like this or it'd be connected like that, but a one-to-one perpendicular connection is suspicious in its own right, so bear that in mind. And so you could use the general length of branches to give yourself information as to where best to check to put your time in for proofreading. This is a merger here too. This is probably large enough that you'd want to get rid of it. So probably get that out there too. One thing you could tell is like, oh, it probably goes this way and it probably goes that way. But here's a little perpendicular branch that's very thin, connecting not really well to that. So probably just zoom in on that and take a look. Yeah, so you can see two unique different ERs here, and what connects them has no ER. So pretty good indication that that's a merger. So that's how you use two similar cells to help trace both the cells at the same time. Hope you guys enjoy this video, and I'll see you in the next one. Take it easy.